Alright, finally get to make a new video for you, picking up a slightly new concept and putting it in a different place. So I get to, on February of 2016, make you a video. I'm going to talk some more about factoring and solving trinomials, but want to point out a couple of situations here now where we've got to do a little manipulating of the equation before we actually begin. And you can see this problem right here is different than the ones you've been solving because we don't have it equal to 0, and we need to have it equal to 0 in order to factor it so that we can use our multiplication property of 0 at the end. So I do want to subtract 21 from both sides, so that gives me x squared minus 4x minus 21 equals 0. Then I look for my two magic numbers that multiply together to give me negative 21 and add together to give me negative 4. Those two magic numbers are negative 7 and positive 3. So that is my factorization, x plus 7 times x plus 3, which means either x minus 7 equals 0 or x plus 3 equals 0, which means that either x is equal to 7 or negative 3. Another example of this, we have 3x plus 2 equals negative x squared. Now I could move the 3x and the 2 to the other side, but in this case I am better off if I add x squared to both sides. First of all, it only takes one step. Second of all, I would like to always have my a equal to 1 whenever possible. And if I moved everything to the right, my a value would be equal to negative 1, and we don't want that. So if I add x squared to both sides, I can then look for the magic number, two numbers that multiply together to give me 2 and add together to give me 3. Those two numbers are 1 and 2. And that means our factorization is x plus 1 times x plus 2. And that means that either x plus 1 equals 0 or x plus 2 equals 0. And if that's the case, then x is either equal to negative 1 or negative 2. Now we're going to look at a couple of problems that we can solve actually by just factoring out a greatest common factor, and won't have to look for our two magic numbers. Here I have a situation where I only have two terms. I have a binomial, and this is a great time to look for a greatest common factor. In this case, each of these terms has an x in it, and so I can factor out the x, and what I'm left with is what it takes to multiply together to get x squared minus 9x. So that'd be an x and a minus 9. And this is just like before. Right? Here I have two things being multiplied together. Either x is equal to 0 or x minus 9 equals 0. And of course, if x minus 9 equals 0, then x equals 9, and therefore my two solutions are 0 and 9. Another example of this, different sort of example, but another example of using the greatest common factor. If I had r cubed plus 3r squared minus 54r. Now I have a cubic term, and that means that I'm going to have three answers. And what I should notice, and what you should notice, is each three of these terms has an r in them. So if I factor out an r, I'm left with r squared plus 3r minus 54, and that's in parentheses. And now I can factor r squared plus 3r minus 54 into its two terms, the two numbers that multiply together to give us negative 54 and add together to give us 3. That would be r plus 9 and r minus 6 equals 0. And so now this means either r equals 0, r plus 9 equals 0, or r minus 6 equals 0. And of course that means that either r equals 0, r equals negative 9, or r equals 6. And then I can just write that in my answer down here, negative 9, 0, and 6. Now I want to look at another situation where using a greatest common factor can be very helpful. If I had 2a squared minus 6a equals 20. The first thing, of course, I want to do is get the 0 on one side, so I'll subtract 20 from both sides, so I'll have 2a squared minus 6a minus 20 equals 0. And it looks like now I'd have to try and find two numbers that multiply together to give me negative 40 and added together to give me negative 6. But I have a little bit of a shortcut I can use here, or a method that'll help me, and that is if I recognize that each of these terms is divisible by 2. And so it factors to be 2 times, in parentheses, a squared minus 3a minus 10. And now I have a trinomial that I'm going to factor using my two magic numbers of negative 10 and negative 3. And of course that will factor to be a minus 5 times a plus 2. And that means, of course, that either a minus 5 equals 0 or a plus 2 equals 0, which means that a is equal to 5 or negative 2. Now I want to show you a very specific and special type of factorization. And this special factorization is called the difference of two squares. If I have two terms, if I have a binomial that has two terms and both of the terms are perfect squares, for instance, if I had x squared minus 64, right? Both of those are perfect squares. They are the perfect squares of x and 8. So this is going to factor to be x plus 8, x minus 8. And that means our two solutions, of course, are negative 8 and positive 8. I'll give you another example. If I had 16r squared minus 169. All right, well, 16r squared is the perfect square of 4r, and 169 is the perfect square of 13. And it'll always be one of them's going to be plus and one of them's going to be minus. And so we now know our two solutions are negative 13/4 and positive 13/4. So that is the difference of two squares.